Here we have the characteristics of sheared edges. A piece of metal is cut and it consists of 4 zones: the rollover, the burnish, and the fractured zone, and the burr. The size of the burr can be minimized by adjusting the gap between the punch and the die. For the cutting forces, it is important to determine press size. The cutting force F in sheet metal work can be determined by this equation, where F stands for the force, the cutting force, the S stands for the shear strength of metal, the T stands for stock thickness, and L per meter length of blank or hole being cut. And since the shear strength is much more difficult than the tensile test, we need to calculate it using this equation. The clearance in sheet metal cutting is the distance between punch cutting edge and die cutting edge, and it typically varies between the ranges of 4% and 8% of stock thickness. If it's too small, the fracture lines pass each other, causing double burnishing and larger force. And if it's too large, metal is pinching between cutting edges and excessive burr results. Here we have the clearance in sheet metal cutting, and it is calculated, the recommended clearance is calculated by C equaling to ACT, where C stands for clearance, AC stands for clearance allowance, and T stands for stock thickness.